We're recording. So the question was, what does it mean, no space to write, when using sort? That means, so sort in Bash is falling back to a disk-based sort. If it doesn't have enough room to fit everything in memory, it will spill over to disk. So it could happen that you're trying to sort so much data that there's not enough disk wherever you're using, whatever sort is using an intermediate file. So not enough space in the disk spillover for sorting. So that's hard drive space. Yeah.
Does it write to disk or does it write to the temp folder?
Well, basically, it's if it runs out of memory on the system to sort the data that you have, then it will spill to disk. So temp folder is one aspect of disk, one part.
Because on Linux, the temp folder, I think it's mapped to memory.
I mean, usually it's in memory, but the whole case with all this stuff is that you don't have enough memory to fit it all. So in that case, these things that you think will be on memory, they might actually spill to disk. It's kind of like swapping. This thing can happen.
Could you actually clear the temp file on the cluster?
Yeah, you can make more space on the cluster. So the question was, can you clear the temp folder on the cluster? So everything in Scratch you can delete essentially and make more space. And you can also see on the nodes when you log into them how much space they have. I think it's like df-h or something. Let me get this so we can see it. So df-h is a command, for example, showing me that I'm using 88% of my hard drive capacity, so I need to be a little careful with 201 used. Yeah. Yeah, so usually an operating system will automatically clear the temporary files out as it needs it. So they do this often every day or every night. Yeah, something like that.
Do they need to download the new for the final project?
I'm sorry, a new.
For the final project, something afterwards I mean, I can't erase that folder.
You can't delete that folder?
Yeah. I gave folder for
Uh-huh. So you can't delete? I can't delete the Git folder that I cloned? Okay, so what was the answer over there?
Just use like rm-rf or
Yeah. Just use rm-f or -rf to recursively delete everything. But be careful with this one because this is like the hammer command. This is like light everything on fire. It's going away. Never see it again. So this overrides all the permissions on the folder. They'll say that you can't delete them when you try to delete them. But if you force removal, then it will just delete them for you. Yeah.
You know, like you had us first like clone the Git code, right? And then you updated the Git. So what is it? Because I thought it was like Git pull or something to update like our version. So like like we could do some stuff to the versions and files. But ideally we want to update with new files or even like replace old ones with new ones that you.
Yeah. So the command for updating files on Git.
the two.
Yeah, so it is git pull.
You told me to use git pull. No, it's error.
Git pull and got some error. That we'd have to kind of diagnose it. But it's possible that you have merge conflicts. If you make one change one place and another change in a different place, then when you git pull, Git does not know how to combine these changes together because you wrote to the same part of the same file.
So let's say we alter any of the files in that directory, you can't pull it.
It's only so Git has a strategy. It'll say merge made by recursive strategy for merging files together. It's just if you write to the same place in the same files, then is when you have a Git merge conflict. And maybe we could talk more about this like in a different lecture if people are really interested in knowing more about Git and the branching model. It's good for software engineering, but here I'm just hopefully we're not dealing too much with merge conflicts and that kind of thing. Hope not. Other questions? Comments on the homework?
Oh, what is your suggestion to where should we host the code for the project?
Where to host the code?
Because for GitHub, if we create a queue, then we cannot make it private.
Okay. Yeah, no need for it to be private.
Okay.
Yeah. Anywhere is fine. It can be public. In fact, I encourage you to, one of the things we talked about was having this be a portfolio project that you can show other people and say, look, I know how to do stuff with data. So
Yeah, we just wasn't sure if you want to make it public.
no, it can be public because all our projects should be different. Yeah, I mean, we'll be using probably similar techniques, but it can be public. Okay, so you should be happy with yourselves about the homework. You all used a cluster and pretty much process an arbitrarily large amount of data. So that's really cool stuff, and those techniques scale up that far. I'm happy with all that, but a few comments specifically. I thought this thread in Piazza was really wonderful. So this one went really long. It was like, what's going on? Trying to figure out the sorting by a column. So what I did in class, I'm pretty sure I did -k = 2 to sort on one column. So the correct one was the key 2, 2 to sort on only one column at a time. So people looked into this and figured it out, and I'm really happy with your problem solving skills on here. So thanks for doing that. So I looked a little bit at the logs, and I saw kind of a puzzle that there were 52 assignment submissions in the class, and yet of the job logs there was only 44. So people submitted assignments, but yet there's no record on the cluster of them having done the work. So how could this happen?
What do you mean by a log?
A log, so you're using a cluster. Everything you do is recorded there.
It appears in SQ, that's a log.
So log, I just mean a record of everything you do. Every time you log in, every time you submit a job in Slurm, every time you sbatch or srun, that creates a log in a log file, so we can go back and, anyone can actually go back and see who did what when, and that's helpful for debugging and this sort of thing. So there were 8 that had assignments but no logs. What?
You can run it locally. You can run it in your local computer.
Run it on your local computer?
Yeah. I mean, you don't need to use the. I mean, yeah, that's the point of the assignment.
Yeah.
Does that account for you?
You can do it.
Does 44 account for people who submitted multiple jobs?
44 distinct user IDs is what I'm talking about. Yeah.
If someone didn't use sbatch, will the job log record their activities? Like,
Yeah.
if you use sbatch, they just use bash.
Yeah, so So what if they don't use SBatch? So the problem was didn't use SBatch to submit. SBatch or srun, either one will create a log. So if you do not use SBatch or srun, this is what it means to run on the head node. So SBatch or srun actually accesses the workers. You know, you go from the head node to the workers and run your script there. So we have all your login credentials, so I logged in as you guys to see what these people did, and yeah, they were all mostly running on the head node, which is fine. It's just not how you're supposed to, how I taught, and not how you use the cluster. So for the next assignment, we'll use the cluster again, and we'll make sure we all run using SBatch and srun, and I'll make that more clear. But I was glad it was that, because I was worried there may have been some academic dishonesty, which doesn't make much sense if you have a system that logs everything you do. You know. Anyway, so the problem, so the solution is to use SBatch. Use SBatch on the cluster, essentially. That's really the right way to do it, best practice. All right, since we got everyone in class, who is still looking for a partner for the project? Raise your hands. So, okay, Rishi, and what's your name? Haran. Okay. Maybe you two both raised your hands, so I only see two. Oh, Alex too?
Yeah.
David, that's right. David. 3, anyone else need a partner?
So how many people can be in the group?
2 or 3. Okay, so I suggest that you 3 are a team because you're the only ones not accounted for. If you're still stuck later on this afternoon, shoot me an email and we will see what we can do. Okay, so we got that. Okay. So let me remind you, yeah.
I have a question about the project. The proposal is due today, and how many questions we should ask for the proposal? Like 2 or 3 or 1?
How many questions for the proposal?
How many questions should come up?
I think one broad one is sufficient, or several specific ones. Because if you ask just one really specific question and it turns out to be really hard to answer, or you can't answer it with that data, then you're kind of stuck. But if you just give like kind of a general direction of what you're interested, where you want to go, how you plan on doing that, that's what we're looking for in this proposal.
We should submit a PDF or
Yeah, PDF or one word or one half-page Word document, anything like that is fine. And make sure you put all of your names on it for your teams.
Can you change the topic after today?
Yeah, you can change it if you go and find out that it's not going to work at all. Yeah. Oh yeah. So the groups on Canvas. Canvas has some feature to make groups. Are you able to like see this as students and make groups? Huh?
If you're using Git or something, I don't think it's useful.
Well, I'm just thinking for the submission so that I can record your submissions. Or see who did what.
I think Git would still be. I mean, because for 141B, Nick's using GitHub Actions, and that I think tracks commits and stuff. So I guess you could use it.
Anyone know what's going on today? Huh? Protest. Does sound like a protest. Okay, your question.
I just don't think Canvas teams are really useful for you, but if you use like GitHub Classroom, you can like assign people to groups there,
Okay.
and you can like, and then you can just get the, if you want to check like git logs and stuff.
Okay. Cool. Well, I will look into that. But in the meantime, just one person from each group submit something on Canvas, and so that I have something to look at. Other questions? Yeah.
How big should the project be?
How big should the project be?
Yeah, because your like the example question you gave us doesn't seem to define the scope for the project.
So I think you're asking how big should the project be? So my answer to that is as big as you like. So this is your chance to do what you will with it. I mean, show me what you can do. Show me your creativity.
Does that include from the earlier exploratory data analysis to statistical inference and to prediction?
Yeah, any of the above. Yeah, I mean you can choose one particular aspect of that. We've done some of the exploratory and other stuff in the assignments that we've done so far. I mean we've looked at it and used the data. So it's going to be the same data set, but you can do exploratory type questions or predictions, statistical inference, machine learning, whatever you want, whatever floats your boat, visualization.
Is it combined or choose one?
You probably want to choose one to make it a little more specific, but I will give you more guidance on the project later after we do this next homework. So more guidance to follow. All right, Jared? Okay. Yes?
On the proposal, like your description, you said you give us a link to the 3 data set we used before for our homework.
Uh-huh.
So for a project, we have to use the 6.6 gigabyte one, or we can use like the data set before that.
Yeah, you can use any of the data sets, or more than, multiple of them, or I can pull some more data out of the actual database for you. So there's a database underlying it, and I can pull more fields and more tables. If you're interested in a different type of question, you need more data. Yeah.
And for the language, are we supposed to use R or other languages that we like?
Use any technology you want.
How are you going to judge on the code quality for different languages?
How will I judge on the code quality? So the reader has done all the grading so far, the reader and the TA. I am going to look at the projects and what you do for the projects. So I'll be looking for kind of the basic things that are across all languages. For example, the magic numbers, these sorts of things are not specific to any particular language, really. So, yeah, and it's not too focused on that, honestly. It's more about the creativity and the scope and the work that you show me that you put into it. Okay, so focus more on that and don't be like too exacting on all the code. It'll be obvious who, based on past experience, who puts in work into this and makes it look really good, and that's what's gonna care most about. All right, show you what we did last time. We talked about shared memory parallelism. In R, you have something like this. Make cluster 2L type equals fork. So this is when we get these really efficient copies by forking the process. That's what's going on with this R code when we make a cluster. Let me make this a little higher. And you'll have an opportunity in the next homework to use this, as well as Python, which I'm going to talk about later today. I want to show you a little more about what the command line can do. We use bash in the command line to analyze our data and understand our data, but you can actually use it very powerfully to control your computer. So what I mean by that is, here's some commands. Oops. Got an R process going over here. sys.getPID 16973 is my process for this number. There's a command kill in bash. What do you think it does? Kill 16973. Make it go away. Boom, it's gone. Terminated. 15. Okay? So you can control your computer in this way, not just process data. You can make basically arbitrary things happen in arbitrary ways. Let's explore a little bit more here. So we can do this, something like cluster eval q, is that the way it is? CLS sys.getPID. Okay, so we've got these processes inside here. Suppose everything's gone haywire and I want to kill these processes. I could do the same thing that I did in the previous screen and just issue a kill command for those, like in that way. But how do we pull it out of the actual data itself? So suppose that we know the parent process ID, sys.getPID. The parent process is 16942, and these are the children processes. I can find the children processes right here. pgrep, let me close this, pgrep dash p, what were they? 16942. 16942. Okay, so this pgrep dash p is p for process, g for grep, just like grepping through our big data file. We can find the processes that are children of 16942, and it's these two ones that were forked out of it. So, do you think we can just pipe this to kill? Will this work? Yes? No? Maybe? Maybe. Let's find out. Okay. So it gives me some kind of warning message. Kill, blah, blah, blah. I don't know. It didn't appear to have worked. And if I evaluate my code on my cluster, I see the children are still here. So nothing happened. They didn't get terminated. So the thing that kill is telling me is that it does not actually accept input through standard input. So it doesn't accept standard input was the problem. Write that down. Kill does not accept standard input.
This is not actually guaranteed.
No, I'm just writing it down. I've got it all written up in the notes, but you mean you want me to write it in the notes?
Yeah.
Okay, okay. I'll do that. Okay. Problem. This is the problem. Standard in. So we have to get the standard output of pgrep to somehow be passed as the operands to kill in order to kill both of these at one time. Anyone happen to know the way to do it? Yeah?
Do you use a dash after kill?
Possibly, but there's a general way that I'll show you here. So this general way is called xargs. So xargs solution, use xargs. So xargs is a program. It takes standard input and converts it to arguments, command line arguments, essentially. Let's see it work. So I can pipe it to xargs and then call the kill program. And now I see no error message. And if I evaluate this, if these are killed, then it should tell me something is wrong with my cluster when I do this. So error reading from connection because the children were killed and this cluster is now bad. I've messed it all up essentially. So again, here was the command. And xargs converted the standard output into a command line argument to the kill program. So this is an example of Unix being really powerful and flexible and letting you combine all kinds of things in really interesting ways. So you can do this and do arbitrary data analysis, do arbitrary commands on your computer using these types of techniques. Xargs, it's one of those kind of meta programs that's really powerful. It's like a kind of a force multiplier. So, any questions on what I did there? I just wanted, yeah, Pearl.
I'm confused. So normally you're saying normally you would do this in R, but you do it right here as well.
I'm just showing you kind of how to use the pipes in the shell and bash to control your computer and do arbitrary things on your computer. That's the point of this. And I can also use it to interact with R, in this case, killing the child processes. So there. Killing. Gruesome language. Anyway, processes are gone. Okay, now let's talk about Python. Bye-bye R, quit you. Okay, I want to have a little bit of a discussion about this, kind of get some collective input. So what is Python used for? What's that? Everything. Everything. What isn't it used for? Yeah.
Data analysis.
Data analysis. Analysis. What else?
Web scraping.
Web scraping. 141B, right?
No, we did actually talk about this because of the fire and the class data.
Oh, really? That and databases? That's supposed to be the main content. 141B. I shouldn't say that. Okay.
So unfortunate.
Yeah. Okay. Making web?
Web development.
Web development? Wells? Never mind. Okay. All right. Machine learning, yeah. Data analysis, machine learning, AI, all that fun stuff. Okay. Yeah.
Like general purpose software.
Yeah, so everything, general purpose software development. Okay, and along with this, everything, I like to put system administration on here too. So systems administration is kind of the stuff I just showed you with Kill and Xargs and Bash. Kind of controlling your computer, making arbitrary things happen. Okay, so why do we like Python? Or why do people in general like Python?
Nice syntax.
Nice syntax, yeah. So syntax, Python was one of the only languages designed from the very beginning to be read. And this is the main realization of the creator, Guido van Rossum, was that you read a program many more times than you write it, typically, especially with once you're not students and once you're in a place with 1 million lines of code base. Mostly you read all these things and try to figure out what's going on, and then you make a small change. Versus while you're a student, you just like write hundreds and hundreds of lines of code, say, oh, it's perfect now. That's the difference between work and being a student. Yeah, so people tend to think it has nice, readable syntax. Lots of packages. Packages. So there's something called the standard library. And the philosophy there is batteries included. So any distribution of Python has this standard library installed where you've got like 50 packages at your hands that you can just use. You don't have to go install everything, NumPy and SciPy. You have many very handy tools that you can get done with just the standard library. And the philosophy is batteries included, everything you need to be productive right now. Which is another one, productivity. So it's pretty easy to get going quickly. Yeah.
It's really popular.
Popular, yeah, that's important. As people keep telling me about getting jobs and stuff, they're like, oh, I want to learn what's in the job ad. So, natural. I don't blame you. Okay, and a side effect of this popularity is that it's available everywhere. Everywhere. So if you have a Mac, then you don't have to install Python. You've already got it installed. Any Linux or Unix system, you don't have to install it. It's already there. Typically, you'll have to go install R if you want it. But you have Python with all its standard libraries. So just like on the cluster, you can go use all that stuff. It'll just be there waiting for you. Yeah, cross-platform. So, but let's talk about differences between R and Python. So we can understand these historically. R started out as basically focused on data analysis. So it went from data analysis to some more general applications, more general things. Versus Python, it went from general purpose, and then people used it for data analysis, machine learning, and all that other stuff. They built it on top of an existing general purpose language. With R's use case, interactivity was important. Interactivity is important for R. So then, let's make a list of how they might be similar and how they're different. Differences. what are some similarities between R and Python? I guess I'm presuming that some of you already know some Python if I'm going to ask you these types of questions. So maybe before we do that, let's ask real quick, who is pretty familiar with Python right now already? Oh, good. Okay. So, awesome. You'll know what's going on then. Right? Okay, so what are the similarities?
Both can do stats.
Both can do stats?
General data analysis.
Okay. Both have general data analysis. Can do. So in particular, Python with the libraries NumPy and SciPy and Pandas. Yeah, stats models is pretty close to R. So they both have the same computational model of in-memory collections of homogeneously typed memory. That's what they're built off of, NumPy. Anyway, so that's a mouthful, but they're pretty much the same thing once you do that. Okay, what are other similarities between the two? Yeah.
Rather than both described as object-oriented languages?
So both can be object-oriented languages. Okay. I don't know. Because they both have functional aspects too. So I don't think either of them really fall that cleanly into the object-oriented versus functional spectrum of things. Yeah.
Those are scripting languages.
Oh yeah, good. So both are high-level scripting languages. There's even a class in the ECS department called scripting languages where they study R and Python, right? So this means you're able to be productive pretty quick. You're not moving memory around in general and doing really low-level stuff. It's the high level where they focus on. I feel like I was explaining this to someone and completely missing the point. High level means that you can have one line of code to read a file or something. It doesn't mean you're like better at programming than someone who does low-level programming. Low-level programming can be way harder than high-level programming and often implies a much greater level of expertise around a computer. So that's what I mean when I say high level. All right. So along with them being high level, they can both be used as glue languages. Yeah, so glue languages. And the meaning of this is of a glue language is it holds together a bunch of compiled code, or wraps a bunch of compiled code. So you have a interpreted kind of slow. It's slow because it's an interpreter, but it's easy for interactive use in R and Python. But NumPy and all the math functions in R, these sorts of things are compiled and they're very fast in general. So we wrap all this Fortran and C code that's been around since the 1970s. We just keep taking it along and along. And even Julia is still using some of these Fortran and C libraries. They just keep wrapping them with higher level, with other wrappers, because this old code is really robust and fast. What is a non-glue language? So this means that so C is not a glue language so much, because C is a low level itself. You write the code in C. I mean, you can make it combine things together, but it's not really its purpose. A glue language should really be high level and make it easy to wrap things and interface to different things. And R and Python are both good for that.
Yeah.
Yep.
What
High level.
examples of low-level jobs? Like low-level. Low-level.
Okay. So, let me maybe put this as a side note. Low level concepts. So these are the things that you might learn in some sort of computer science class that I've never took. So all you computer science majors out here, you can say what class you would learn this sort of thing. So low-level things are like opening sockets and writing bytes. So sockets are these general purpose things for handing data back and forth, copying memory directly, or accessing individual bits of memory, this sort of thing. Interfacing to operating system, so directly calling operating system calls. I don't know. Is there a CS class where they do all this sort of stuff? Probably 50? 50 or 150? Okay. So ECS 50 or 150? 150. So with a high-level language, we just assume that someone has done all this. Because this is a bunch of nitty-gritty code to get this sort of thing to work. And it's well worth knowing, but it's just by assuming that we can do it all, we're operating at a higher level, closer to the problem domain that we care about, like statistics and data analysis. We want to do high-level stuff in general. Okay. So they're both, another thing is, they both have reference implementations in C. So you can use the C language to create a whole nother language. That's low level. Creating language in a language. Implementations in C. And a reference implementation means that it's sort of the standard by which everything else is judged. Or that's the way it should behave. Okay. All right, now what are some differences? Yeah?
I know that RS starts the indexing at 1 and then Python uses.
Oh yeah, okay. So R is 1 indexed, Python 0 indexed. Yes, this is an important difference. So that means you start counting at 0 versus counting at 1. And sometimes you'll go online and see people hating on one language because it's 0 index or 1 index, but it's like, who cares? This is just completely a cosmetic thing. You get used to it if you're not. Yeah.
R is vectorized.
R is vectorized. Yeah. Yeah, so R is vectorized, and so is NumPy. Yeah. Like NumPy. So this is what I'm talking about when I say NumPy is a lot like R. Yeah. Popularity? You think one is more popular?
Python is apparently more popular than R.
Python more popular than R?
Especially in the field of machine learning and artificial intelligence.
Okay. Yeah, I'll give you that for machine learning and AI. So you think of things like TensorFlow, what's that? PyTorch. All these things, they have yeah, they have all the stuff ready to go in Python. You just drop it in and use it. Python is faster? Yeah. Not really. It can be in some cases. So Python can be faster. So can R though. So it depends on what you're doing. Really depends on what you're doing. But if you're in the interpreter and either one of them, they'll both be really slow relative to a compiled language. I'll say that. Both are pretty slow. But the vectorized underlying code is fast. That's where you get the speed with both of them. Okay? Heather.
R to work with the cluster. Can you do it in Python also?
R to work with a cluster? Yeah. So all this parallel computing, Python has a built-in module. I think it's called for multi-processing. Yeah. So Python can do the same thing. Multi-processing dot. Yeah, it can do all kinds of stuff like this. Now, by the way, what I'm showing you here is IPython. Specifically, I'm using Python 3, version 3.72 up here. We have version 3.4 on the cluster. So you can use this to do your next homework assignment. IPython is REPL, read, eval, print loop. It's kind of friendly. It's got a lot of interactive features that lets you get help, quit, do Unix type commands, inspect your objects. So I usually use it for development. You can get it with Anaconda. And if any of you have it open, any Python interpreter should be fine. If you just type in Python, get whatever you get, you can follow along, do some things. Okay. There were a couple other differences that are relevant to statistics. So R has more statistics software. I mean, R has, I don't know how many thousands of packages on CRAN with all these types of statistical tests and methods. These people who are publishing in statistics, they're publishing R packages, so you can use new methods in that way. Less so in Python. There's also missing data is baked into R. Is baked in, is, what was the word? Well supported. Well supported in R through NA. So we have this NA in R. This is something that makes R kind of different than other languages. And it's also why I'm excited about Julia, because they're doing some really cool things with how they're handling NAs. And that was formerly something that really only R did very well. Okay. All right, so Python was in the news last July. What happened last July? Yeah, so kind of an interesting bit of trivia. Last July, Guido van Rossum quit his role as the benevolent dictator for life, BDFL, of Python. So this was Python's governance model before. Guido van Rossum invented Python as a joke. Well, Python is named after Monty Python, if you know what Monty Python is. Monty Python. Just look at some images. So this was this British sketch comedy that was really super corny. In the Holy Grail, the meaning of life. Okay. Yeah, so anyway, it's meant to be kind of fun, and it's got some fun baked into the whole language of Python itself. So he invented it as I think a summer project in, I want to say, before 1990. And then recently, like within the last 5 or 10 years, it's become much more popular than it was. And people like it because it's readable. Easy to use, all these things that we talked about. But now Guido has retired, and actually I was reading about it, and there was kind of an interesting statement. He said why he quit. He said the straw that broke the camel's back was a very contentious Python enhancement proposal, where after I had accepted it, people went to social media like Twitter and said things that really hurt me personally. And some of the people who said hurtful things were actually core Python developers. So I felt that I didn't quite have the trust of the Python core developer team anymore. I didn't know that that was the backstory, but it's all these things that kind of matter. So they've got a new governance structure. They're using like a committee of 5 people, and they're figuring everything out, and it's all going to be fine, and Python's going to go on and be popular for many years to come. So don't worry that Guido is gone if you're sad. A little sad. Okay. Another thing I should say here. If you say that X is better than Y for any technologies, X and Y, this is rarely true. So they have the language wars. I think I mentioned this in the very beginning of class. Language wars are boring. And they're usually, people fighting them usually don't really know that much about the languages that they're talking about. They just like, oh, I learned this one first, so it's the best. So I encourage you to learn multiple languages. It will help your understanding of any of the languages that you do know. And you'll see what concepts are the same across different languages and which are different, and where some excel and where some don't excel. It's just that different things have different strengths and different philosophies. So one example of this is, here's an example in R. So an example. So people say R is bad because partial argument matching. Partial argument matching in R. R, if I do something like X equals R norm 1, mean equals 10. Oops. Run that line, that's fine. So the full argument name is mean. I can do the same thing, but instead of typing out mean directly, I can just pass it, or just use a partial argument match. And it gives me a warning because I've set my options in R to warn me when I do this, because I don't want to do it because I think it's bad. But for interactive use, this sort of thing can be really helpful because you don't have to type out the whole command. You can just type, or the whole argument, you can just type part of it and press enter. So what I was saying with the historical context is that R was meant to be interactive first. Interactive and easy to use. So this partial argument matching is nice for that sort of thing. With Python, this sort of thing will not work. So I can do the same thing in Python. Import random. I do random.normalvariate mu equals 10, sigma equals 1. Run that line. So it gives me some output. It likes that. That's fine. When I try to do partial argument matching, instead of just sigma, I'll call it sig. Run this line, copy and paste, run it. It says type error. Normal variant got an unexpected keyword argument sig. So instead of just matching it partially, it threw an error. So this is Python's design philosophy. How can I see Python's design philosophy? Anyone know?
Go to the documentation.
Go to the documentation. Weird import. Yep. I'll show you the weird import. The Easter egg. Import this. Okay. So I just typed in import this. This is kind of a fun and whimsical thing where it's saying everything that is good in Python. Beautiful is better than ugly. Explicit is better than implicit. All these things about how you should think about Python code. Here's one. In the face of ambiguity, refuse the temptation to guess. So partial argument matching here can be seen as some form of ambiguity. And the refusing to guess is Python just throwing an error and saying, no, not doing it. Refuse to guess, just throw an error instead.
So if you type sig, it doesn't kind of give you a, sometimes it doesn't remember what the
An auto complete, yeah. So sig, if I press tab here, yeah. So now it completes for me. So yeah, there's no reason really not to do it. Sig equals 1. Sig equals 1. All right. So can you think of any other? What are some other examples of how of things in R that are good for interactive use? Can you think of any? But might not be in Python? Yeah?
Well, R can make plots really easily.
Make easy plots? Make easy plots. But you can do that pretty easily in Python too, with matplotlib, with
When you have to import the libraries.
oh yeah, import the libraries. Have to import the libraries. Whereas in R, you don't have to import the libraries. But how many objects are in your global workspace from the very beginning? Do you know? There's a lot of objects. I mean, there's on the order of over 1,000, a couple thousand in R, of objects that you can just access. Like the letters T and C, all these these are functions in R. Not so in Python. Let's see. So I can show you what Python has. Is it built-in? Built-ins. Built-ins dot. So if I look at the built-ins, I can see the things that are built into the Python interpreter. So there's a lot fewer of these, so we don't have to import to get any of these built-ins. In contrast, in R, all this stuff would be, much more stuff would be available. Another thing I thought of was the formula syntax in R. And non-standard evaluation in general. So non-standard evaluation in R lets you kind of control the language and do whatever you want with it. Python doesn't let you do this. Probably for good reason. Okay, so let's talk a little more. Important difference is the reference semantics. Yes.
Why do you use dash before the?
This?
No, use dash I6 dash I3.
What are all those things? So those are details of IPython that it's saving every result that I make into a variable in IPython. And I can go back and look at those objects. But that's kind of an implementation detail of IPython. It makes it convenient for interactive use, but it's not part of the Python language. So didn't mean to show you that. But this is a pretty big difference between R and Python here. So let's demonstrate it. Reference semantics. And So I need to define this term, reference. So it basically means multiple variables refer to the same object. Refer to the same objects. Same object. I'll show you how it applies in Python. If you have x equals 10, 20, 30, something like this, copy and paste, run it over here. So when I'm typing in R, all this stuff is I said R, typing in Python, it's all very similar with my workflow. So I can check the type of x. This is like the class in R. I can do basic things like the length of x. Okay. I can make an object y equals x. And then I change y, I modify it. y1 equals 100, 200 here. So y looked just like x. X was 10, 20, 30. Now y is 10, 200, 30 because I just changed that. If it has reference semantics, then what should x look like?
Same as y.
X should look the same as y after this. It does. So it changed the original object. They're both pointing to the same object. This is what reference semantics mean. You have to. You don't have to use this. I mean, I can make a copy of it, but it's kind of requires me to be very explicit about making a copy. So I can do copy.deepCopy of x, y2 equals copy.deepCopy of x. Yeah.
Why don't you just use clone?
Clone? Is that a method?
Yeah.
Okay.
Dot copy also, right?
Dot copy. You think that'll work? Will that make a deep copy or a shallow copy? Okay, let's find out. x2 equals x.copy, right? This. Oops. Run it. So the question, is this a deep or shallow copy? Hmm? So, I didn't mean to get into all this really CSE stuff. Sorry about this. A deep copy means it recursively goes through and copies every single element. Shallow copy means it just copies the outer data structure, which means if we change it like as we did before, it will also show the change because they'll be pointing to the same object underneath. Hmm? I really can't hear you.
It just like give you a key, and if you change this short copy, you are also changing the original.
This copy will also change my original copy? Yeah, if it's a shallow copy, that's what will happen. Okay, so x2, oh, sorry, x2, so if we modify it, x2, 1 equals hello, we'll change it. Fine. x2 changed. Did x change? I'm surprised. Therefore, it must be deep.
That's a shallow copy.
Hmm?
Yeah, if you do like the object of deep copy, like this. Then
Wait, was x2 copying x.copy? Okay, well. Okay. This is a road I don't really want to go down anymore. How much more time do we got? 10 minutes. Okay. All right. What can we do in 10 minutes? All right. Let's talk about just these basic data structures. This will be a little bit, we'll have a little bit of fun with this. I need 2 volunteers.
Okay, I'll go.
Wait, Rodrigo, you are already a volunteer. I need 2 volunteers besides Rodrigo and Tianjing. Okay, Jared. 1 more. Who else? Who's going to volunteer? It's okay. It's really easy. It's not like measuring points on the board. It's much easier. Okay, come on up. Well, actually, wait. Let me prepare it. Or you can prepare it. Here. Write down 10 and 20 on this pieces of paper. So, another term is a list. So it's just an ordered collection of objects. These are these basic things that I'm working with inside here. X. Clear? I'll make one. L equals, what numbers did I tell you to write down? 10 and 20? Okay, 10 and 20. 10 and 20, these are the numbers. And a tuple is the same thing, but it is an immutable ordered collection of objects. T. I have L and T. Okay, now I need my 2 volunteers. You've got your papers that say 10 and 20 to come on up. All right. You're first, so you can be the list. You're second, so you can be the tuple. What's your name?
Zach.
Zach. Zach and Jared. So this is Jared. And Zach, you are the tuple. Zach the tuple. Okay. So, Jared, what is your type? Look up there. Say it loud. I'm a list. Of course you are. Zach, what is your type? Oh, sorry, you're a list. Oh no. You should be a tuple. Let me fix that. Yeah. Now what's your type? Tuple. Thank you. Okay. List, can you give me your 0th element? 10. So you just hold this out. Hold your 10 out. So you have these 2 things that you're holding in hand, and your hands are your memory. So you're holding all your data inside your memory, and when I say give me the 0th element, wrong order, you say this, okay? L010. Zach, same thing. Can you do this? Okay. Indeed you can. Get the 10th. That's your 0th element. So this is the first thing that you're holding. So these tuples and lists are acting kind of the same. We can look up based on index, and that's what I'm doing when I call the 0th element. Same thing if I do the first element. List, give me your first element. 20, that's right. We're 0 based. So L and T both give 20. Thank you very much. All right. Now, if I want to change this element inside a list, equals 200, I can do this. So I'll let you change it. Pretend you're writing another 0 on there. Here's a pen. Change it. That's what this L1 equals 200 is doing. He is actually writing and changing what is inside his memory, inside his hand. Okay, now when I select L1 from you, what do you get? 200, yeah. Okay. Okay, Zach, I want to try to do the same thing with you, a tuple. L1 equals 200. Now, I'll give you a pen, but you got to think about what you are. You are immutable. You cannot be changed. Zach is who he is, and he will not be changed. So what will happen when I try to do this with Zach, when I try to assign here? Thanks. That's L. Here's T. I'll try and run this code. Say, typer! And then go like this. No, I'm not doing this. Okay? Tuple object does not support item assignment. Okay. Thank you very much. Good job, guys. All right. Thank you. In the same way, we could take L and I could append to it. L.append 500. So L has a whole bunch of methods, and if I type L dot and then I press tab inside IPython, I see all of these methods. Because it's mutable, I can reverse it, I can sort it in place, I can remove things, extend it, append things. If I append something to it, 500, I see that I have just appended 500 to it. The same way with the tuple, T dot, I press dot and tab. Now I see far fewer methods because the tuple is immutable, so I can't really do anything to it. I can't modify it in place. I can only count or find the index of things. So a tuple is kind of a restricted data structure compared to a list. Okay. We have 4 minutes. I don't know if we can do another round with the next data structure. Oh heck, let's try it. I need another volunteer. Yeah? Okay. Parul? Okay. You can be a dictionary.
It's smart already.
Yeah, dictionary. Okay, so a dictionary. So what this is, unordered collection of key-value pairs. So, whereas the tuple and the list, they were holding the things in order in memory, you have an unordered collection. So your data just sits inside some box. You don't know which one comes first. You only know keys and values. Okay? So Parul is a dictionary. D. So your keys will just be A for 10 and B for 20. Okay? So D, oops. What is the value of A? 10? 10. Awesome. Okay. We got it. So in the same way, this is looking up a key. Looking up keys. We can also modify. If I say $D$B equals 200, then I can run that line, and you will take a pen and just write 200 on your. Okay, yeah. So you change your B to be equal to that. We look it up now. DB, get DB.
200.
200. Awesome. Okay. Thank you very much. Now, one more thing. What if I try to index using an integer number? So if I try to get your 0th element, I said that dictionaries are an unordered collection of key value pairs. So what will happen if I try to go D0? It will look for a key called 0, it won't find it, and it will give me a key error, I expect. D0. Okay? D0. Key error! No! Can't do it. Okay. Thanks, Pearl. Alright, more fun next time. We'll learn about generators and teach you how to do the next homework assignment.
What is the best way to grow a list dynamically?
Append.
Append,
Append is fine in Python.
but not in R.
Not at all.
So how would you do it in R?
You have to pre-allocate for what you need.
But if you don't know,
You can use this kind of doubling it every time idea. So whenever you fill it up,
okay,
whenever you fill up the list, instead of adding one more element, you make it twice as large as it was before,
and then you
fill in those elements.
so you
on more.
pre-allocate like in the loop.
Yeah, you have to do that kind of thing.
Okay.
And it's a big pain.